Hey everybody, this is Mr. Ainsworth again, and we are in, yes, Math 90. Ooh, yeah, Math 90. And we are in Chapter 3 review, Part 2. Yes, Part 2, and I only gave you 1 through 19 odds instead of all 20. Okay, and remember, this is a video, so pause and play, go at your own pace. And yes, I give you the answers, so you can check at the end, right? You should always check as you go. All right, so do yourself a favor and, hmm, pause and play. All right, watch a few, try a few, and then press play and then check it. Okay, just don't listen to the video and just copy. Okay, that's not going to help you much. Try something and then press play and check, and then pause the video and try it and then check it. Okay, that's the best way to use videos like this. Okay, if you're totally clueless, watch it. Okay, but you shouldn't be. All right, you should pause and play through the video. All right, let's get started. Let's take this first one down here. We got negative 12 here, which is less than or equal to n divided by 2, and our goal is to solve for n. And guess what? It's being divided by 2, so you always do the inverse. The inverse of dividing by 2 is called multiplying by 2. All right, so you multiply both sides by 2. When it comes to negative numbers, put in parentheses, okay? Make it look like multiplication. If you want to do it on the right side, it looks like this. All right. 2 times n divided by 2, the 2's cancel, giving you 1. 2 divided by 2 is usually 1, especially today. And today is December 2nd, it's Sunday. Ooh. Okay, a few more weeks left before the first semester is over. Okay, 2 times negative 12 is negative 24. All right, and that's less than or equal to n. Okay, now we're going to switch the order here. So let's write that down. So switch order. Let's spell that a little bit better here. All right, switch, there you go, order. To do that, okay, you have to understand one principle. So let me deal with numbers first, okay? I'm going to go off to the side. All right, so if we all know that 3 is obviously greater than 2. So if you switch an order on this right here, if 3 is greater than 2, then guess what? 2 is less than 3. And so notice if I switch the order, I switch the inequality so that it makes sense. Okay, if 3 is greater than 2, then 2 is greater than less than 3. All right, now with variables, it looks like this. If x is greater than 2, well, that means 2 is less than x. All right, that's just a little example. So over here, we have negative 24 is less than or equal to n. Well, that means that n is greater than or equal to negative 24. All right, now we know that negative 24 is a solution, so because this is greater than or equal to. So we find 24, negative 24 on the number line. There it is. All right. It's a solution, so we're going to go closed. And all numbers greater than negative 24 lie to the right. So x can be any value, including negative 24 and to the right. All right, this right here tells me that's closed because negative 24 is a solution. All right, if it was strictly greater than negative 24, I would go open. Think of it that way. All right, do you hear me, my friends? Do you hear me? All right, hallelujah. All right, here we go. All right, so now that's number 1. Number 2, number 3, because I assigned the odds. Okay, you're so lucky. If you want extra practice, do the evens. Okay, let me see the test. Let me see, I'm assigning the odds, but who knows? The evens may be on the test. Keep that in mind. Okay, just a little hint there. Okay, let's see, those are perceiving me well, we'll probably do that, okay? But if not, just do the odds. Okay, so here we go. Negative 1 is greater than negative 4 plus b, whatever b is, right? B is a variable. All right, divided by 22. Okay, now we got addition and division. All right, now we got to clear the fractions first. Let me write that down. You got to clear fractions first. Notice that I'm going slow. All right. All right, and the way you do that is multiply by the denominator all the time, okay? Multiply by the denominator. If you look at review 1 and what we did, I did that every single time. Anytime we had a fraction and I want to clear the fractions, I look at the denominator and I go, okay, it's 22, and then so multiply by it. Just like I did over here, I multiplied by 2. Well, over here, I got to multiply by 22. So give the left side a hug. All right, multiply both sides by 22. And remember, everything has to be balanced here, okay? All right, notice that I do the same thing on the left as I do on the right. Okay, if you multiply by 22 on the left, you better do it on the right. If not, it's not going to be balanced and your answers aren't going to make sense. Now, 22 times negative 1 is obviously negative 22, and that's going to be greater than, let me see, 22 times this whole entire thing divided by 22. The 22's canceled 1. 22 divided by 22, and I say divided by because it's in the denominator. Okay, you always divide by whatever you see in the denominator. Like up here, it was 2 divided by 2, and that's 1. 22 divided by 22, and that's, guess what? That's 1. So all you get is negative 4 plus b. So negative 4 plus b. I'm going slow for a reason. Okay, now that b is being added to negative 4. So now we're going to switch to addition. I'm going to add the opposite. The opposite of a negative 4 is called plus 4. All right, add the opposite right there. Add the opposite. So what do you get? Well, the negatives cancel, the opposites cancel as error here. And negative 22 plus 4, well, that's negative 18. Okay, and that's going to be greater than b. And just like I did up here, you switch the inequality. So if negative 18 is greater than b, that means that b is less than negative 18. You got to switch the order again. Notice that I'm repeating my techniques. Okay, so get used to it. It's coming out here. So you find negative 18 on the axis, okay, and it's right here on the number line axis, x-axis, number line, same thing. And since b has to be less than the negative 18, negative 18 is not a solution. So you go open. Okay, this tells you that negative 18 is not a solution. So go open there. All right, and all numbers less than negative 18 lie to the left. All right, less than to the left. All right. Also, the inequality, guess what? It's pointing in the same direction. Okay, that's why mathematicians came up with that symbol, because it points to the numbers that are less than the number. Okay, to the left. So open to the left. Negative 18 is not a solution, and that's why it's open versus closed. So pay attention to details there, guys, because guess what? If you make that close to negative 18, it is wrong. Okay, do you hear me? All right, come on. Do you hear me? Do you receive it here? All right, here we go. Now, next one, number 5, you got negative 1 is less than or equal to a plus 7 divided by 4. Oh my God, another fraction. So what did I say earlier? And number 3, I said clear the fractions first, multiply by the denominator. So what in the world is the denominator? Well, it is 4, right? Look right there. It's being divided by 4. So what do? You multiply by 4 here, okay? And you multiply it by 4 on the left-hand side as well, okay? So you multiply by 4 on both sides. You simplify. 4 times negative 1 is 4. Just like 22 divided times negative 1 is negative 22, 4 times negative 1 is negative 4. You guys, you got to look for patterns here, because it's pretty obvious. A positive times a negative is a negative, okay, every single time. And over here, 4 divided by 4 is usually 1, especially today. All right, it's Sunday. It's the big G's day today, and hopefully you guys went to church and was thankful for everything you have. Okay, enough of that. Enough of preaching. Here we go. So we got a plus 7 here. A plus 7. Okay, and you got to solve for a, and it's being added to 7. So what do? You subtract 7. Why? Because that's the inverse. Okay, 7 minus 7 is 0. Especially on Sunday. And then a negative plus a negative is a bigger negative, and so you get negative 11 is less than or equal to a, and that means that a is less than or equal to negative 11. You got to switch the order again. Notice that I did it 3 times in a row. Switch the order again. Okay, so if negative 11 is less than or equal to a, I forgot to switch the inequality. Come on, Ainsworth. Negative 11 is less than or equal to a. I just caught a mistake right there because I'm being too silly. I'm being silly. Got to focus. Okay, come on, Mr. Ainsworth. Focus, focus, focus. Okay, that's going to be greater than or equal to negative 11. And by the way, when you check number 5, let's go to check number 5. Look at this. Look right here. Number 5. A is greater than or equal to A is greater than or equal to negative 11. All right, so if you would have checked your answer, if you did make a silly mistake like that, you would have said, hey, it's not less than or equal to, it's greater than or equal to. Why? Because when you switch the order, you switch the inequality. Okay, now negative 11 is the solution because of the equal sign. All right, so we're going to go closed here. All right, because negative 11 is a solution. It's right here. So you got to find it on the number line. Okay, and let me see, all numbers greater than negative 11 or greater than or equal to negative 11 lie to the right. Okay, and if you check number 5, okay, right here, okay, notice that it's closed at negative 11 right here, and it's to the right. Okay, always check your work. Okay, quality is more important than anything. Okay, I'd rather have you guys do 2 problems right than 11 problems or 10 out of 11 problems wrong. Okay, I can care less whether you do your homework. I care about doing it right. All right, I mean, if you're going to do your homework, you might as well do it right. I mean, just think about it right here. Don't waste your time and do half of them wrong because you're going to develop bad habits. I mean, think about it. Be smart, be wise. If you're going to do something, you might as well do it right. Think about it, okay? It's important. All right, quality versus quantity. Quality versus quantity. All right, this is what you're looking for right here. You're looking for quality. All right, like I keep on saying, if you do 9 out of 11 problems wrong, you get worse. If you do 9 out of 11 problems right, then you're probably getting a little bit better. I mean, because everybody makes a few mistakes here and there. I get it. I do it all the time. Like you saw me here, I just made a simple mistake here because I'm goofing around too much. I gotta focus, just like I tell you guys. All right, but you gotta focus on quality. Quality of work matters. All right, now on this one here, we got 92 is greater than or equal to negative 4 times the quantity 1 minus 3m. Now, there's different ways of doing things. You can divide by negative 4 first. You could do that, or you can distribute through. All right, I don't care how you do it. I mean, it all depends on your style. From experience, I see a lot of people distributing. Okay, distributing twice. Okay, you could do that. All right, that's one way to do things. Okay, there's 2 ways to do this. And it doesn't matter how you do it as long as you do it correctly, okay? So if you do distribute, you get 92 is greater than or equal to negative 4. Negative 4 times 1 is negative 4. And then negative times a negative is a positive, so you get plus here, okay? A double negative. A negative times a negative is a positive. And negative 4 times negative 3 is positive 12, so you get plus 12m here. All right? You got to distribute twice and take care of the signs, okay? A double negative is a positive in English and in mathematics. All right, if you're not negative, you're positive. Just think about it. All right, I mean, seriously, if you're not negative, you're positive. I mean, in English, it's still a positive. You're non-negative. This is actually a word in English. All right, what are you? You're positive. All right. I'm a positive guy, so hey, check it out. There we go. Just threw a little mathematics and English for you right there. All right. Even though I'm a math teacher, I apply it to everything in my life. Okay. Are you hearing me, guys? Are you hearing me? All right. All right. So let's add the opposite here. All right. Negative 4 plus 4 is 0. Opposites always cancel to 0. Hopefully you get that. And negative 4 plus 4 equals 0. Opposites. Okay. Always add to 0. Key concept used all the time. Okay, right here. 92 plus 4 is usually 96, and that's greater than or equal to 12 times m. Now look at it. I could have said 12m, right? But it's 12 times m. All right, and you have to know that 12m means 12 times m because you always do the inverse. All right, if you want to solve for this variable, you do the inverse. So instead of multiplying by 12, well, we divide by 12. All right, and guess what? 12 divided by 12 is 1, and 1 times m is m. The only thing that you need to do is figure out 96 divided by 12. So what is 96 divided by 12? I mean, is it 5, 6, 7, 8? I mean, try 7. 7 times 10 is 70. 7 times 4 is 7 times 2, excuse me, is 14. 70 and 14 is 84, so that's not it. So let's try 8. 8 times 10 is 80. 8 times 2 is 16. You got 96 here. Ooh, yeah, it's 8. All right, so 8 is greater than or equal to m. That means that m is less than or equal to 8. All right, once again, you switch the order again. I've done it in each problem, guys. Hopefully by now you figured out how to do it, okay? And guess what? 8 is a solution. Why? Because this is less than or equal to 8. All right, so you find 8 on the axis here. It's right there. 8's a solution, so you make it closed. All right, and all values that are less than or equal to 8, like 7, 6, 5, 4, 3, and all the numbers, all the real numbers here, okay, all of these guys are less than or equal to 8. All right, so when you get your last inequality there, you go ahead and graph that puppy, okay? All right, that's number 7. Now again, this is a video, right? And so remember, when you work with a video here, you pause, all right? You play, all right? Listen to it, and guess what? You rewind to, all right, to listen multiple times. Now, I may be saying the obvious, but believe it or not, I've watched people use videos before, and they do not rewind and listen multiple times, even though they don't understand. You got to do this, guys. I mean, be wise. If you don't get it the first time, or if I'm going too fast, okay, rewind it. It's a video. You're lucky that you have the technology here. Okay, when I was a kid, back in the 70s and the 80s, I didn't have this technology here. I did everything on paper and pencil, with paper and pencil. No videos, none of this. Okay, I worked hard. Now it's your turn. Okay, so here we go. Negative 280 less than or equal to 8 minus 6 times the quantity. Notice I said times right here. Times, okay? It's times the quantity, 6x plus 6. So what you want to do is distribute the minus 6. Now, I said the minus 6 because if you add the opposite, look at that. It's a negative 6. So you got to understand that that 6 that you're distributing there is not a positive number because it's being subtracted. If you add the opposite, like you see me in red right here, all right, you have to understand that you are distributing through or multiplying through a negative number. So negative 6 times 6, well, that's negative 36x, okay? 6 times 6x is negative 30, excuse me, negative 6 times 6x is negative 36x. Now, if you guys are watching the video here and you're wondering if you can write it as 8 minus 36x, the answer is yes, okay? In fact, most of the time I do that. I'm just trying to illustrate in the video here that 6 is a negative number, because if you don't know that, you're not going to get the answer right. Now, negative 6 times 6 is negative 36. So write it as a minus 36. Or plus negative 36, however you want to write it. Minus 36 plus negative 36 is the same thing. Now, you have to add like terms. Now, 8 minus 36 are like terms. So I'm going to rewrite this. So negative 280 less than or equal to 8, and I'm going to switch the order here, minus 36, and then I'm going to bring over the plus negative 36x over here off to the right. So what I just did right there is just reordered. That's the only thing I did. Reorder and add like terms. That's what I did in blue right there. 8 minus 36. Just reordered it, grouped them up. And guess what? 8 minus 36? Well, if you don't know that's negative 28, just think of it using money here. You've got $8 in your pocket and you take away 36. I mean, obviously you can't pay off the debt here. So you're gonna give the person the $8, but you're still gonna owe them something, right? And so if you take 8 minus 36 right up here, you better be negative, and it's going to be negative 28. If you guys want to use a calculator here and there on the, as you do your work, fine, go ahead and use it. As long as you understand the steps, that's what I'm gearing for. Okay, now add the opposite. Opposite of a negative 28 is 28. Okay, now let's say you have $28 in your pocket, but you owe somebody $280. All right, that's a big debt, right? So you can't pay off your debt. If you have 28 bucks in your pocket, you can't pay someone 280 bucks. I mean, just think about it. You're gonna still owe them a lot. All right. So what is negative 280 plus? Whoops, not minus, but plus. You gotta type it in right. Plus 28. Well, it's going to be negative 200 some, right? Because you're going to give them the 28 bucks, but you still got a lot to go. How about negative 252? All right. So you got negative 252 is equal to negative 36x. Excuse me, less than or equal to. There we go. You got to keep the inequality there. Let me write this a little bit more clearly here. Okay, bring down the negative 36x there. Okay, now I'm going to divide by a negative. Now you got to be careful here. When you divide by a negative 36 on both sides, all right, let me rewrite it over here. Let's a little bit more clearly here. Negative 252 is less than or equal to negative 36x. When you divide by a negative 36, you got to switch the inequality. I'm not going to go all in depth on this because I've done it so many times in class, but just remember when you divide by a negative, so when dividing by a negative number, all right, switch the inequality. I'm paying attention to, or going slow and paying attention to all the little details and writing down the things that, get people or cause people to make a mistake because uh, I don't want you to make the mistake, okay? I want you to focus in on the details and remember what I'm saying here. All right? So notice when you divide by a negative number, all right, this is true for division and multiplication, either one. When multiplying or dividing by a negative, you better switch the inequality. So what is negative 252 divided by negative 36? Well, if you don't know what it is, all right, like I keep on saying, just use a calculator, okay? I want to focus more on the steps versus, just the, simple division things, okay? Divided by negative 36, type it in. Make sure you use the negative button on the calculator and not the minus sign. Otherwise, you'll get an error, okay? And then hit go. Oh, I didn't type it incorrectly. I put in negative 256. So let's start over. So negative 252. A calculator is only good as a person typing in the numbers, right? Good input, good output. Bad input, bad output. Okay, so we get 7. So what do we have? We have 7 is less than or equal to x. Okay, and if that's true, then x is greater than or equal to 7. And this is number 9, right? So let's check it. So number 9, x is less than or equal to 7. Okay. Hang on, what happened here? Let me pause. Okay, so I did. Here I am paying attention to details, and I didn't even switch the inequality here. So look right here. I have to switch it from less than or equal to, not less than or equal to, but to greater than or equal to. So this is a mistake right here. You got to switch it. Let me put it in red right here. So you go from less than or equal to greater than or equal to. When dividing by a negative, switch the inequality. Okay. This is the reason why I give you guys answers, because what I just noticed is that obviously when I checked here, obviously I looked at it and go, something's wrong. So I go back up here and I thought about what I was saying and what I was doing. And I wrote it down, but I didn't do it. So this is something that you have to remember here. When you divide by a negative, you got to switch the inequality from less than or equal to greater than or equal to. Okay. Now, after that, now you got to switch the order. Here we go. I've done this in almost every single problem on this review. So when you switch the order, if 7 is greater than or equal to x, that means that x is less than or equal to 7. Now when you check the answers, look right here, x is less than or equal to 7. All right, notice it's closed and to the left because numbers like 6, 5, 4, 3, 2, 1 are less than or equal to 7. Okay, now I'm on the right track. Okay, so now you graph the inequality. So you go back here. This is going to be closed. All right, at 7. So find 7, go closed. And all numbers that are less than or equal to 7 lie to the left. There we go. So hopefully I'm paying attention to the details here. I'm going slow on purpose. I'm writing out the things that you need to remember. Make sure you do the same thing here. All right, just don't solve the problem. Write down key things that I'm writing down and practice like a madman. Okay, number 11. We got a few more. We got some literal equations here. Now, literal equations, all they are equations with variables, okay, with very few numbers, okay, and you're going to be solving for the indicated variable. In this case, you got to solve for x. So let's highlight it. It's right there. Now, x is, you're subtracting c from x. So what we want to do is, well, first of all, let me divide the sides here in left and right sides. You have to add the opposite on both sides. So the opposite of a minus c is a plus c. All right, and that's all there is to it. Now, g and c are not like terms, so you write it as g plus c is equal to, these cancel to 0, and you get x. Or you can switch the order and say x is equal to g plus c. And then you check number 11. All right, x equals g plus c. So we know you're good. All right? All right, here we go. This is not that bad, okay? Now, next one here, we got to solve for a right here, and z is equal to b minus ma. All right, so what we want to do is to solve for a right here, I'm going to cancel out the b by subtracting b. All right, so I get z minus b, which cannot be combined because they're unlike terms. You can only combine like terms, and z and b are not like terms, so just write it as z minus b. Just read it, z minus b. It's that simple. B minus b is 0. They cancel, and you bring down the, not ma, but a negative ma. Why? Because it's being subtracted. Okay? Look at it. I'll even highlight it. It says minus. Minus, okay? Now you're trying to solve for a. Excuse me for a second. I was just trying to clean up my writing right there. Trying to solve for a, and it's being multiplied. Everybody say multiply. You're multiplying it by negative a here. Okay, so what do you want to do in here? You want to do the inverse in here. And you want to divide by negative a. Excuse me, negative m. All right, both sides. And so what you do is you divide by negative m, and you simplify. These cancel to 1, and 1a is a. So a is equal to z minus b, all right, divided by negative m. All right, and then you check. Number 13. And you'll notice that 13 looks a little bit different here. Notice that m is positive in the denominator. Okay, and up down on our solution is negative. All right, so no big deal. So let me rewrite it like this. Okay, so I'm just going to switch the sides here, and a is equal to z minus b divided by negative m. Okay, so what you can do is bring this negative up top. So I'm going to rewrite it as negative of z minus b divided by m. Just bring the negative up top, distribute it through, and watch what happens. Negative times z is negative z. Negative times a negative is a positive, so you get plus b divided by m. And guess what? When you check it, right here, you get negative z plus b divided by m. So I know that I got 13 right. So sometimes when you check your work, the answers may look a little different because guess what? Answers can be expressed in different ways, even though they could be equal. So they're equal even though they look a little bit different. Now, for those people that are going, hey, you know, Mr. Ainsworth, I solved it differently and I got the same result. And I said, fine, because some people may want to do this. Some people like to bring the variable term that they're looking for, like this variable term here, a. You're trying to solve for a, so it's the variable term minus a here, minus ma. You want to bring it over here on the left. All right, so if you're going to do that, you can add ma on both sides. This is a possible way to do it. This is method number 2. So if you do that, and this approach may be a little bit easier for some, all right, you get z plus ma, can't be combined right there, all right, is equal to b. All right, now let's subtract z. So you get m times a is equal to negative z plus b. You can write it as b minus z, or you can write it as a negative z plus b. Why? Because b is positive up there. I added the opposite to both sides. And at this point, you can divide by m because it's being multiplied. And you get 1a, or a here is equal to negative z plus b divided by m. And notice that these things are the same. So method 1 or method 2 gives you the same result. All right. Next one. Now proportions here, when you're solving for a here, proportions can be solved by cross multiply and divided. You could do that. So cross multiply. I'm going to do it this way just because we solve proportions in class this way. And the step 2, you divide if necessary. Okay, so let's go for it. So this cross product here, a times p, oops, I'm sorry, a times p is equal to the other product, m times n. So m times n. Cross multiply and then divide. You're solving for a, so divide by p. So divide by p on both sides, and guess what? A is equal to m times n divided by p. And if you check number 15, let's check it. M times n divided by p. It's right here, mn divided by p. So I got 15 correct. All right. All right, all right, all right. Here we go. All right, next one. Got to solve for a again. So, oh, jeez, that scared me. Okay. That was my mom calling me. I'll call her back in a minute. All right. I'm at home taking my own time to help you meatballs out. All right, so here we go. It's a times c. I'm going to rewrite it like this. A times c is equal to r divided by d. Now, you could divide both sides by c. Although if you do that, don't write this down. If you do this right here, this gets a little complicated. R divided by d divided by c. And you'll notice in the answer on number 17, it doesn't look like that, does it? Okay, so I would not approach it like this. Okay, so I'm going to rewind here. All right, and I would multiply by the reciprocal. Okay, so let's write that down. So multiply by the reciprocal, which is something you've seen me do in class. All right, now the reciprocal of c is 1 over c. So if you multiply both sides by 1 over c, so times 1 divided by c times 1 divided, oops, come on, Ainsworth, 1 divided by c, there we go. Okay, let me split the side so you can see it. So I multiplied on the left by 1 over c and multiplied on the right by 1 over c. The reciprocal of c is 1 over c. Just like the reciprocal of 2 is 1 over 2 or 1/2, the same thing. Now, what's cool is that reciprocals always multiply to 1. C divided by c is 1, all right? And what's cool about that is that 1 times a is a, and guess what? You just solve for a in one simple step by multiplying by the reciprocal. When you multiply fractions, you multiply the numerators. R times 1 is r. D times c is what's called dc. And then when you check number 17, you get r divided by dc. R divided by dc. Oh, CD, dc. This is r divided by dc. The same. Why is that? Well, c times d is equal to c times d. The order in multiplying doesn't matter. Order in multiplication, all right, doesn't matter. Which is hopefully known to you. I mean, just think about it. 3 times 2 is 2 times 3. Okay, the order in multiplication does not matter. Okay, I just did a little simple example there for you. Okay? So always check your work, my friends. Always, always, always. Okay? On the next one, we're going to solve for A again. Now, A is right here. It's being multiplied by C and then added to B. Well, I would always add the opposite first. So let's split the sides. Here we go. We're going to subtract B. All right. On the left, we get G minus B is equal to C times A. All right. C times A. Notice that I didn't say CA. I said C times A. The B minus B cancels out to 0, obviously. Now, you always do the inverse. If you're trying to solve for A, they cancel out the C by dividing both sides by C. C divided by C is 1. 1 times A is A. So I get A is equal to G minus B divided by C. Or if you want to switch the order, you say A is equal to G minus B divided by C. And then you check. All right, check it out. It is right here. Here's number 19. So look right here. G minus B divided by C. Let me just put it. Ooh, right. Let's see if I can get both of these guys. There we go. So notice number 19 is correct. So right here. Okay, G minus B divided by C. That's all there is to it, guys. There is to it. Now, this is a video, and videos can be used in many good ways. Okay, remember, pause, play, rewind, as I keep on telling you guys. And if you want some more practice, guess what? All right, do the evens. All right, for more practice. In fact, I will give you extra credit. So do the evens, all right, for more practice. If you do that and you show me, I will double your points. How about that? So instead of 4, I'll give you 8. All right. So plus 4 points, I'll double the assignment. All right. As long as they're correct. They must be correct, though. Must be correct. Okay. Must be correct. And steps must be shown. Steps must be shown. All right. So for those people that are watching the video, you just got an extra credit opportunity. All right. This is Mr. Ainsworth. I've had fun with you, and I look forward to seeing you in my next time with you in class. Okay. Give your best. All right. Make yourself proud. I'll see you later. Bye-bye.